Here's our fourth example. Here's our function. Notice this function is an exponential function. It has reflection across the x-axis or the horizontal asymptote, and it has a reflection across the y-axis also. And it has a vertical shift upwards. It has a horizontal shift to the left of 2 units. Okay, so this function has everything under the rainbow. The first thing we're going to determine is this an increasing or a decreasing function? Increasing or decreasing? And what do we look at when we determine that? We look at our base. Okay, decreasing. We look at our base. Notice this is our base here. This is the number that is raised to an exponent. So my base in this case is 5/6. This number, 5/6, is less than 1. So a is less than 1, but it's greater than 0. And what happens when I have this situation? This means that this is decreasing. So automatically, I'm going to draw decreasing was this way, right? It increases that way, and it approaches y = 0 that way, just to have a reference, and we're going to use that later, okay? The next thing we're going to find is our y-intercept, and for our y-intercept, we evaluate the function at x = 0. So this becomes 5/6, and then negative 0 plus 2, that's my exponent, plus 4. And that equals negative 5 times 5/6 to the negative 2 power plus 4. Now, when we have an exponent here and we have a quotient, what we do is we distribute that exponent to each one of the numbers. So this will be 5 to the negative 2 and 6 to the negative 2. This is how it looks like. It's going to look like negative 5 times 5 to the negative 2 power and 6 to the negative 2 power plus 4. And this becomes negative 5. And remember, we don't want negative exponents. So this number comes down to the denominator. And that makes that exponent positive. And if the exponent is negative in the denominator, we bring it up to the numerator, and that makes the exponent positive. Plus 4. That equals negative 5 times 6 squared is 36. 5 squared is 25, plus 4. Now we multiply by 5 here. We can cancel out a 5 here, and this leaves me with a negative 1 in the numerator. So that equals negative 1 times 36, negative 36, over positive 5 plus 4. And now we need to look for common denominators. The common denominator here is 5. So this becomes negative 36 over 5 plus 20 over 5. And that equals negative 16 over 5. And if we change that into a mixed number, that's negative 3, which makes 15, and 1/5. So my y-intercept is 0, negative 3 1/5. Okay, now let's do horizontal asymptote here to the side. Horizontal asymptote is going to be located at plus 4, y = 4. Okay, now we have all the information we need. We can start plotting on our coordinate plane. Let's see. I'm going to plot my y-intercept, 0, negative 3 1/5. That means 1, 2, 3, and a little bit more, right about here. I'm going to sketch my horizontal asymptote at y = 4. 1, 2, 3, 4 right here. This is my horizontal asymptote. And I'm ready to sketch the graph. Now we have to do a couple of reflections. Let's start by looking at our a value here, our base. We said it was less than 1, so that means I have a decreasing function. That's what I have originally. So if this is my horizontal asymptote and I have a decreasing function, my original function, not the parent function, but this function without any reflections, this function here but without any reflections, it's gonna look more or less. Now if this is my horizontal asymptote, this is more or less what this is gonna look like. It's gonna decrease and it's gonna approach that asymptote, right? That's more or less just a guide so that I know what I'm gonna do now. The next thing I'm going to do is I'm going to reflect that sketch, which is not precise. I'm going to reflect it across the y-axis. So if I reflect this across this axis, if I fold the paper down the y-axis, the reflection is going to look, I'm going to use another color for the reflection. It's going to look like this. I approach the y-axis and then I go up. So it's reflected across y, okay? More or less. This is just a sketch. The next thing I'm going to do is I'm going to reflect across my horizontal asymptote. Remember, when we reflect across the x-axis, the parent function's x-axis is also the horizontal asymptote. But since I moved the horizontal asymptote up 4 places, I also move. It's like moving your x-axis up 4 places also. So I'm going to reflect across this horizontal asymptote, and the final graph then should look, if I reflect this yellow one, right? This one was the original one. This is the reflected across the y-axis. So this is the one I'm going to reflect across my horizontal asymptote. That's my last reflection. So it's going to look like this, more or less. It's going to go down like that. I'm sorry about these lines. It's hard. Okay, and then I approach my y-asymptote, my horizontal asymptote, hit my y-intercept. And you get the idea, okay? This is a reflection of that second transformation that I made, okay? And that's your final graph. And you can verify this. You can use WZ Grapher. You can go to Wolfram Alpha and input this this function, and you can verify that what you have done is true. I have a sketch here. Here's the sketch of the function I was talking to you about. This red line, notice down here, this is the function that I input, the same one we did on the video. And this is WZ Grapher. 2 things I want to show you. The y-intercept, this is my y-axis here. Notice when I place my cursor on this axis here, it gives me the coordinates of that point. So we know it's a y-intercept, so x is 0 and 3 is negative 3.23, negative 3.2. We had gotten a y-intercept of negative 3 1/5. So that is the same thing as negative 3.2. So there you have the intercept. Also, notice that the function is coming from up here. I'm going to move this over a little bit. Oh, I see. Let me see if this lets me here. Notice as I move this over, notice this red line. It starts approaching the value of 4. And we know that 4 is our horizontal asymptote. So the more I move over to that side, notice how it gets closer and closer to 4, but it never actually touches it, okay? And if it seems like it does reach the value of 4, all we have to do is zoom in on that value. Let me move up a little bit. We can zoom in into the graph and notice that it is not touching it, okay? So that's what's going to happen with this function. I'm sorry about this. Let's see if I can grab this cursor here so I can move my function to the side, back over to where we were in the beginning. Whoops, again. Okay, there. Oh, Let me move this over down here, and that way I don't have to fight with it. Okay, so I'm moving over again. Let me zoom out a little bit so you can see the whole graph. Okay, there it is. So notice that the red line will approach the value of 4, but it will never touch it, and here's the y-intercept that you found. And that's how your graph is going to look. And if I move down, you'll see that it keeps going downwards like that. Okay, so that's one way of verifying that what you've sketched is correct. I encourage you to go back. I've given you 4 or 5, I think 4 examples. Go back and do them on your own. Try them on your own. Do what you can, and then watch the video again and see where you failed or where you missed a step. Okay, well, have fun with this, and I hope you do good on your quiz. Goodbye.